Hi everyone, welcome to week 10. Last week we looked at something called the sine law, which helps us solve any triangle. There are some limitations to sine law, and that's why we're going to complement that with a new law called the cosine law. Now, here's an example of when sine law is not very helpful. Recall that for sine law, that's a setup: a over sine a equals b over sine b equals c over sine c. Now, if you have the situation where you have these two sides and you have the included angle, which means you know small a, you know small b, and you know sine of c, but you don't know these other three things. If you take any pair of equation, there are always going to be two unknowns, so it cannot be solved. For example, if I look at the first two, then I know the numerators, but there are two unknowns, which means I can't really find them. Because remember, you can only find if there is one unknown with one equation. Similarly here, these are unknown, so we cannot find. And in the third pair, again, two unknowns, so we cannot find. Now what to do in those situations is that we can use the cosine law. Here's what the cosine law says. If you're given a triangle ABC, and then you have small sides A, B, C, remember these are labeled as being opposite to the same named side points. And it's kind of symmetric, and it should remind you of the Pythagoras theorem sort of in general. A squared equals b squared plus c squared minus 2bc cosine a. The trick to remembering this is, if you're working with the side A, right, then this angle is going to be A, and in the other terms, you do not use A. It's B, C, B, C. Similarly, if you're working with b squared, this is angle B, and this is AC, AC. And if this is C and angle C, then this is AB, AB. Now this can also be written, what you can do is, this is what we did in week 1. You can solve for cosine A, cosine B, cosine C if you want to find the angles. So in the first one, cosine A is going to equal a squared minus b squared minus c squared over negative 2bc. Similarly, cosine B, b squared minus a squared minus c squared over negative 2ac. And cosine C is going to be c squared minus a squared minus b squared over negative 2ab. Okay, this is giving you the same information, except in this form, it can be used to find the angles A, B, and C instead of the sides A, B, and C. Example, let's say you're given this triangle. First, let's draw the triangle ABC, and I label the sides accordingly. And given that this is 4.08, 4.37, and this is 68 degrees. So I'm trying to find all the other things. So let's start by trying to find the side of the triangle C. So what we have is C squared is a squared plus b squared minus 2ab cosine of C. Plug in these values, 4.08 squared plus 4.37 squared minus 2 times 4.08, 4.37 cosine of 68 degrees. Making sure your calculator is in degrees. You can plug this entire expression all at once into the calculator. Let me do that too. Squared plus 4.37 squared minus 2, 4.08, 4.37 cosine 68 degrees. This comes out to roughly 22.39. But that's c squared, so we have to take the square root. Again, you can do that on the calculator. Square root of 22.39 comes out to 4.73. So we found C. Now we need to find A and B. Now the trick here is you don't have to apply the cosine law again, because now you have an additional information. Now I can use the sine law, because now I have A over sine A equals C over sine C. Now I know this, and I know this, and I only have one unknown. So it's simpler to use the sine law now. So that gives me 4.08 times sine of 68 equals 4.73 times the sine of 8. Going from here to here is I used cross multiply. Right, so the left hand side is 4.08 times sine of 68. That's roughly 3.78 sine A. So recall I'm solving for A, which means if I divide 3.78 by 4.73, I get 0.80 roughly. So A is going to be sine inverse of 0.8. Sine inverse of 0.8, the calculator gives me that to be 53.13 degrees. So first we apply the cosine law to find the side. Then we apply the sine law to find the angle. Now it just gets easier because finding B is now simply 180 minus 68 plus 53.13, because the angles of the triangle have to add up to 180. So this, you can think of this as a general procedure that you will be seeing throughout, that you apply the cosine law once, you apply the sine law once, and you use the sum of angle being 180 property once. I'm going to let you work on this one in the similar fashion, and I'm going to skip over to the word problem. Say, in order to avoid a restricted area, an airplane flies from point A to point C to point B. The distance is 18 and it's divided as 10 and 8 as given. But if there is a military airplane that is allowed to fly directly from A to B, how much shorter is the route? Now, first of all, for any triangle, you can sort of intuitively see that the distance AB is going to be less than 18. The problem is to find how much less than 18. This angle C is not given. Let's say this is 105 degrees because you will need that. Labeling wise, that's going to be A and that's going to be B. So C squared is 8 squared plus 10 squared minus 2, 8, 10 cosine 105. Plug that into the calculator. 2, 8, 10 times cosine of 105 comes out to 205.41. So C is, of course, a square root of 205.41, which is 14.33 kilometers. But that hasn't answered the question yet, because A to C to B is 18 kilometers and A to B is 14.33 kilometers. So how much more is you have to subtract to find how much shorter this distance is? And that gives me 3.67 kilometers. So that's an application for the cosine law.